ladder. Thank you to everyone who is here. You heard that at the beginning of the presentation, but it is very refreshing to see so many people very concerned with sustainability. It's something that I'm very concerned with, and I'm glad to have comrades in arms. That's for sure. So I'm Aaron Engel-Hall, as you heard. I'm one of the team members, one of 7, who took ME 310, Chemical Engineering 310 at Stanford last year. And I'm here to talk to you about our project, which was the Bloom laptop. It was our recyclable product solution to the growing problem of e-waste, a problem that was brought to our awareness by Autodesk last year. So before we begin, I would be remiss if I didn't introduce the rest of the team. This was very much a team effort. Took every ounce of effort from all of us. The ME 310 course at Stanford, just to give you some background, is a year-long corporate-sponsored class where students at Stanford team up with global partners. In our case, it was students in Helsinki, Finland, at Aalto University. You spend an entire year working on a single project. As I'm sure all of you have guessed, our sponsor is Autodesk. And so we are Team Autodesk. And at Stanford, we have Rohan Bove, myself, and Kirsten Gale, who look very familiar. At Aalto University in Finland, we had Juho Patari, Martin Koskela, Linda Liukas, and Sean Song. I'm sorry if I mangled the finish, but I imagine no one would be able to pull me out. It's warning me you're almost out of battery. Okay. So I'm going to try to start us off with a little audience participation. I'm guessing that most of you own electronics, right? Yes, yes. In fact, I'm willing to bet about 90% of you have one in your pocket right now. So just with a show of hands, how many have ever had a broken electronic device? That's what I thought. Okay. How many of you know exactly how to recycle that? So there's a few. That's good. Keep in mind, this is a sustainability summit, so this may not be the norm. And a lot of you don't, and why should you? It's not obvious, it's not easy, there's no recycling instructions on your device itself. And even if you did know what to do with them, you'd probably have to drive about 20 minutes to get to the nearest recycling center. For this reason, most people end up storing their old electronics. I'm sure a bunch of you have that growing pile in the garage that you just don't know what to do with. And that's normal, very common. It's lack of consumer awareness, inaccessibility of recycling locations, and just general inconvenience of the whole process are a few of the reasons why landfills all over the globe are filling up with electronics. And it's this exact problem that Autodesk brought to our attention. At the beginning of the project, they asked us to design a consumer electronics device that is recyclable by the consumer him or herself. And that would help alleviate the problem of e-waste. It's pretty broad, and we like the ambiguity, as they said in class. We embrace the ambiguity. So just a little background on this problem. I don't need to go into too much detail. I imagine a lot of you already are aware of this. But as you know, just to put a few numbers to it, over 2 million tons of electronics became obsolete in 2005. And that same year, only 350,000 tons were recycled. Every year, 50 million tons of electronics are added to landfills. But this isn't even the biggest problem. The most pressing danger is the electronics that don't end up in landfills and pile up in the streets of poor countries where women and children end up picking through them for precious metals. And this is an obvious reason why this is a pressing need, and we need to work on it as quickly as we can. So our team at Stanford researched this problem to try to find the key pressing need that should direct our work. In the interest of time, I won't discuss the 1,000,001 trajectories which we pursued and benchmarked and prototyped and user tested. We could go on and on. I'll just cut to the chase. What we found that contributes most to the growing problem of e-waste is that the end-of-life experience for the user of the electronic device is incomplete. They are completely disconnected from the recycling process. And because of this, there exists a gap between the consumer and the recycler that needs to be bridged. In our case, we were hoping to involve the consumer themselves in the recycling process with the device itself. So I'd like you to meet the Bloom laptop, which was our solution to the growing e-waste problem. It's a laptop that can be easily disassembled in under 45 seconds without any tools. All the materials that require special handling, and there are quite a few in your laptop, like the LCD circuit boards, batteries, things like that, can be easily removed and placed inside an envelope that's prepaid and labeled to a local recycling facility that's capable of dealing with those electronic components. The rest of the laptop, the case, can just be tossed in your home recycling bin. This laptop represents a new class of electronics that are built on the principles of modularity and easy, intuitive disassembly. You can disassemble and recycle this from your couch. So I'll give you a little idea of what this means, this easy, intuitive disassembly. As I mentioned, it's tools-free, and that's an enormously important aspect of design. Although users are happy to recycle, and almost everyone gets that warm, fuzzy feeling when they're being green, what it really boils down to it is that no one is really willing to take it apart. We did a lot of user testing, surveying, and we couldn't find a single person that would be willing to pick up a screwdriver if that was part of the recycling process. You could talk to people who were buying build-it-yourself electronic kits and fries, and they said no way. So it was incredibly important to us that our design is so easy and intuitive that users can disassemble it in 10 steps with their hands. So I'll give you a little walkthrough of what those 10 steps are. Although I don't actually have it broken into 10. But first, remove the wireless keyboard, which I will talk more about later a lot. That gives you access to what we call the bayonets, which are the small swiveling portions that hold down these doors on the inside of the laptop. Once you swivel them, you can remove the doors one at a time and have access, as you can start to see, to the internal circuitry inside. As you can see now, we have the battery and the hard drive and the motherboard, and there are many other components which are obscured from view. The next step is to get at the LCD, and in order to do that, all you have to do is slide upwards on the front portion of the screen, and it will come unlocked and slide upwards and out, and you're able to just remove it easily. The keyboard itself, which you removed in the first step, opens just the same way. Just slide the two halves away from each other, and they'll click and release. At this point, you have your laptop disassembled. You have two piles, pile of the circuitry that you can place inside the envelope I mentioned before, hidden behind the screen, and you have the casing. The casing can just be tossed in your normal recycling stream, and you can get back to watching TV or whatever it was you were doing before that. It's as easy as that for the consumer. It wasn't as easy as that for us, and I'll talk just about two of the challenges that we faced. The first that I'll talk about is the friction hinge. A friction hinge in your laptop is this thing. So I just move the laptop screen, and it stays at whatever angle I decide to put it at. These friction hinges are monstrous things inside your laptop that are made, employ a lot of steel and a lot of screws. Two things which our recycled laptop could not afford. We had to experiment with several different designs to create a friction hinge without the help of steel. And furthermore, for the friction hinge and for everything else in the case, we had to design around the internal components of our laptop rather than vice versa. Large companies like Apple will, great examples in MacBook Air, they design a case and then they show it to the engineers and just say, make the circuitry fit. We couldn't afford to do that. So creating 3D digital prototypes with Inventor software was absolutely essential to create a friction hinge that worked around our components and didn't interfere with recyclability and used almost exclusively aluminum. We usually took our prototyping from sketches to CAD and then back again, and it bounced around this way for a while. Another aspect of our design, which was definitely facilitated by the Inventor software, was working with the incredibly tight tolerances that exist inside our laptop. As everyone here knows, laptops and most of electronics need to be thin and sleek and sexy to be desired by consumers. And in our case, using no screws meant that every piece had to fit just right. Here's a portion, a CAD model actually, of the screen, which demonstrates these tight tolerances fairly well. As you can see, it's outlined, yes, it's outlined in yellow, are these small pieces which we call the press fit guides, which were the channels that directed small flat-headed pins in the underside of the front portion of the laptop screen, which unfortunately you can't see in this image, and were used for the locking mechanism of holding everything in place. We need to experiment with the size of these channels and the shape of these channels and vary them by a few thousandths of an inch at a time And this was incredibly easy in Inventor software and would have been impossible using any other traditional method. In order to find the perfect balance of sturdiness, and easy disassembly, because we need the user to be able to do it themselves, we varied these and printed out at least 100 different copies. Using Autodesk CAD software coupled with 3D printing and laser cam technology was the only way we were able to do this, and it really allowed us to make leaps and bounds. But I'm not going to talk entirely just about engineering challenges. The engineering challenges were some of the problems we faced, but we actually purposely chose to add an extra layer, actually 2 extra layers of thickness, when we made our keyboard wireless and removable. As you imagine, there has to be an underside of the keyboard and a top side of what's left underneath, and those that's some truthfully unnecessary thickness, you might think. But we had discovered something very important in our prototyping and user testing, and that's that we needed to design our product to be green as a byproduct. And what that means is that the wireless keyboard was a perceived user performance increase. Everyone really liked it. That was the selling point. When it gets down to brass tacks and you're at Best Buy and you're looking at 2 laptops, even if you really want to be recyclable, you're not willing to sacrifice any performance in order to have that. So what we want to do is turn it on its head, and we used the pre-existing modularity device that we had used to make it modular and recyclable and disassemblable, and we turned it around and said, look, it's wireless. This is a new laptop, and it happens to be recyclable as well. And this was a motto, green as byproduct, that we adhered to pretty strictly throughout the entire design process, and I believe the Bloom embodies it well. So I'm going to show you a, skip this part? Okay, it wasn't playing well. Well, I'll just tell you, and I'm sure, here, if you search Stanford recyclable laptop on Google, click on the YouTube link, there's a YouTube link that a video Autodesk prepared, which I'm sort of glad I don't have to share because I'm talking it, it's always awkward. But it has some great visuals. It has some of the publisher videos we use, publishers in Autodesk software, that's really easy to use and create, I guess marketing materials would be the right word. It shows a video of the laptop components disassembling themselves and reassembling much better than I could picture in words. And I'm not that good at charades, so I'm not going to act like a laptop. But it's probably worth taking your time to look at, and I can see we're getting a little pressed on time. So I'll try to skip through. As you can see here today, the Bloom represents a new type of electronic device that the team at Stanford and the team in Helsinki sincerely hope to inspire others to pick up where we left off. Modular design and toolless disassembly offer incredibly easy avenues for in-home recycling of electronics. And the modularity further allows us to easily implement this green as byproduct that we found to be so important. I also want to mention there are many other possibilities which I didn't include in this presentation because time didn't permit. But quick repair, very easy repair, is trivially easy with a modular design such as this. We made all the components inside. We sliced them all up and rewired them so that each component had quick disconnect. So a user could, if a portion of the laptop was broken, and it's all too frequent that we would talk to people who said, my USB isn't working and the L key isn't working, so I think I'm going to get a new one. That's a really silly reason to buy a new laptop and toss your old one in the trash. So making these things easily repairable goes really far in making a laptop more recyclable. I'm sure everyone here knows the quickest way to be green is to just reuse. That's something which we looked into, but the current culture of more, faster, unfortunately doesn't really adhere to. This is the Bloom laptop, and if you're interested, please check out the YouTube link online. Before I wrap up, I promise I'll be brief. I want to thank Autodesk for their support throughout the development of the Bloom. Not only did they give us money, which we were very happy for, and we spent every penny of it, but they also offered us mentorship that was invaluable. We had official liaisons who were more than helpful. We had people in the company offering to help us, teach us their software. They gave us their software for free. They're giving all students, anyone with an EDU email address, their software for free. And it allowed us to do things we didn't think possible. But most of all, I really wanted to thank them for the creative freedom that they gave us with the project, and I believe that that was one of the most important factors in the development of the tool. They were always supportive of whatever we were doing, even though we'd have a meeting one week and the next week we'd be going in the complete opposite direction we had told them the week before. And this happened a lot, and they would grin and bear it, and I'm very thankful for that. So the entire Autodesk team from Stanford and Helsinki thank Autodesk, and thank you everyone for showing your concern. So I'm glad to be giving this presentation. So I think I'm supposed to wrap up. I'll wrap up now, and I think we'll have Nathan come up to moderate some Q&A.